Good afternoon, everyone. This is Friday afternoon, early afternoon. You're probably wondering what's on the bench here. What's the old fart doing now? Any ideas, folks? Huh? Building something. You may have an idea what it is. Made that yesterday, and I finished a little more gluing on it this morning, and it's got to dry. Hope I didn't bang into the transformer that time. Probably did. I received this in the mail from Amazon Prime. One of my viewers, I have no idea who it is, was kind enough to send me this meter here. There is no name on it, but there are a couple of videos on a meter that looks exactly like this, except it's orange, and I'm pretty sure it's the same thing. So you know what this is. It's another holder for a digital multimeter similar to the one that I built back there for the Fluke 73. Now, I ran this through the paces of the features I would use on it, and it's very accurate, right up with my Fluke 73. I want to thank whoever sent this to me. Obviously, one of my viewers, a lot of my viewers know I have bad eyesight, and I really appreciate it. But you know me with receiving things, I want to reciprocate by paying you for it. But I can't. But you know who you are. And I really do appreciate it. Sometimes when I make a video and I say I'm having a hard time with this or that, there are a lot of kind viewers out there that would try to help me out, and I sure do appreciate it. But, however, I feel like I gotta pay that person for doing it. That's me. Anyways, there are a couple of, that I know of, reviews on this, and I did look at those videos. One is in great detail, and the other one's just a video about, overall about it, but not having a stand and this and that. Well, that's not a problem because I make my stands out of wood. Hello, Doug. I'm ribbing you again. You know, Doug's a good guy. He likes to rib me, and I like to rib him. If Doug had this, he would make a cardboard stand for it. All right. I played around with this quite a bit yesterday to learn how to use it. It works very well, different from what I'm used to using, but it has a nice big display. And I'm going to set you up on a tripod here so that you can see better on this, and also that I can operate it, because it has 3 buttons on the side and a power button on top. Over here, I believe it's a flashlight, but I have not been able to turn it on. I can't seem to get that to work. No big deal. I wouldn't use that for a flashlight anyways. Now, when I first got this in the mail, it didn't come on. I looked at the book. Yeah, I always read the instructions after the fact. And the instruction says, remove the 2 bolts on the back. B-O-L-T-S. Bolts? So the first thing I looked is up here. I says, that's not bolts. And down here, I put the smallest screwdriver in there very gently. I said, those are just plugs. Well, I wasn't aware. I said, there's no seam on this thing where the back can come off, so you can put 2 AA's, which is what the instructions say it takes. Well, I didn't know, but this is the case. And then when you remove that, which I'll show you, there's a cover and one Phillips screw in the back, and you got 2 AAA batteries, which I stuck in. All right, let me get you on a tripod here, and we'll go over this a little bit. Okay, so the first thing you do, you push it on, and it says auto. Of course, it got Celsius, which I don't use. So you've got a function, I think that is. Embossed, I have a very hard time reading. But Fahrenheit. Okay, it won't stay on Fahrenheit, but not a big deal. But we know that the shop is 73 degrees. So the first thing is they give you a thermocouple so that you can measure temperature. But the book gives it in Celsius, so it means nothing to me. I use Fahrenheit. So it don't tell you, you know, whether you can dip this into a container of boiling hot water, whether it would, you know, the thermocouple in there. It doesn't tell you because it's in Celsius, and that means 0 to me. But anyways, not a big deal. I have multimeters that have these, and I never use them anyways. But it's nice the fact that it has the temperature here, so it has a sensor in the meter itself. So I built the stand so we can hold it up like this, because when you got it down like this, I guess you can see that, but yeah, I can still see 73 degrees Fahrenheit. Okay, so that's fine, but I like to use my meters this way, and I think most of you guys do. Right now, obviously it's turned on, but when it's off, there's no markings here that tell you where the leads go. They're not coloring. No color codes, okay? But when you turn it on, it's very well explained here. The left one is for amperes or milliamperes. The center one is common. And the other one is for volt, ohms, and whatever else, okay? So that's not a problem at all. Then you got your temperature here. And what I like about it, and it's going to be difficult for me to demonstrate, I can't get good camera angles and so forth without hand holding things. But if you want to know more about how this works, I recommend the longer of those 2 videos by 2 different YouTubers. I think one of them is an English guy. He's the one that you want to watch because it's a longer video and he goes over the entire thing and how to use it. The other video is shorter, and really he complains about the no color codes and the fact that it doesn't have a stand and this and that. That doesn't bother me at all, because I'm building the stand to accommodate this. And when the glue's drying, when it's all dry, and that'll be tomorrow, the meter already fits in there perfectly. So it'll be on an angle like this, or as you're looking at it this way, it'll be slanted back like that. Very easy to read. So now, let me get you a cord, and we'll demonstrate the AC function of this meter right off the bat. Okay, now this says auto up on the top, but normally it says auto right across it. Okay, now I got it, it's supposed to be auto, so when you plug this in to the AC, the backlight comes on. It's kind of a reddish, pinkish. Means that, from what I understand, what these reviewers are saying, it means that you're on a higher voltage, okay? So I'm going to plug this in now. I got this cord, clip lead, snap clip leads on. So I think my leads are going to pop off here. And I got to try to reach in and plug it in. Of course, the cord is always backwards. It's got to go in this socket. All right. We don't have any AC on. All right. Now, if I'm going to use my finger because I don't have anything else. 59.98 cycles per second. Okay. Even the reviewers, when they're measuring line frequency, is always that. It's never 60. Okay. There's your line voltage. 118.5. 118 on the kilowatt on the wall. There is no 0.5. The kilowatt don't read all the resolution like this does. So you're on auto. You got a pink background. That means, you know, you can connect it right to the line. And, you know, in the same way with DC voltage. Okay. Now, on DC voltage and line voltage, I verified with my Fluke 73 and this, and they're within 1 volt of each other, which is not a problem. All my meters read within 1 volt of each other, pretty much all the way across the board, and I have several meters. But you can look here where I'm pointing. It says volts, right? Okay. So we know the AC part is very good. And of course, we're reading 59.98 cycles per second. On the little meter or on the kilowatt, it says 60 cycles per second. So whether that's really 59.98, we're not going to worry about that. When you run a generator, it's usually 62 cycles. So it's not a big deal. I don't nitpick like that. This is a damn good meter, and I appreciate the one of my viewers for sending this to me. And I wanted to just show the meter. So unplug the line voltage. Okay, and we will be right back because we got to redo our cords here. Okay, I have got it set on DC. This is automatic. What the heck? It went out. Maybe it was timed. I don't know. I hope the battery isn't going. Now it's back on Celsius again. 38 volts. 38 volts. I don't know if you can see that. Oh, it's so hard to set things up in this shop to demonstrate. But yeah, I'm looking in the viewfinder. It's quite good. Okay, so I'm hooked to the ICO 950B. The voltage is all the way down. The lowest the voltage will go on that ICO is 38 volts, which is, as you can see, I'll use my finger because I've ended before pointers, 38.8, 38.9. It's jumping around. It's very close. So now, this, when it gets up to a certain voltage, the backlight will come on. That is normal, okay? So we're going to crank the ICO up all the way. It only puts out about 420 to 430 volts. That's the max. So, 419. There's an extra digit on this that this don't have. So this is 419. This is my Fluke 73, as you can see. And 419, close enough. Okay, now it'll vary because the line voltage fluctuates here. Okay, so you can see on auto, this will automatically give you AC or DC readings. So that's a very good thing. Now, the instructions are right here. And it takes some reading to understand it. But it's not all that hard. And, there's quite a bit on it, and it's written in English, which is very good. So that's the voltage coming out of the ICO. Now let's drop the ICO all the way down, as low as it'll go, and you'll get about 38 volts. Okay, that's the lowest it'll go. Now, in the book here, somewhere, and I'm not taking the time to look now because it would take me too long. The video would be way too long. If the voltage goes down to a certain level, whether it's AC or DC, from what I understand in the book, it goes into ohms. That's strange. Why? I don't know. But anyways, it's written in the book, and but for me to find it for you now, I'm not going to waste time doing that. The only part I do not understand yet is this here. EF. I don't know what that function is. Non-contact voltage detection. The reviews didn't give that part too good of a reading. It's not all that sensitive, but not a problem. I never use that feature. I love this meter. It's very good, and I want to thank the viewer who sent it to me, because it's not only got a bigger display, but you can see down at the bottom where I'm pointing with my finger, right here, there's volts, okay? All right, so now we know that. So now, let's turn off the ICO completely, and you watch. It goes into ohms. When it gets to a certain voltage, because you see you got 0.325 volts here, that won't read that. That'll go into ohms. Why? I don't know. But it says that in the book. When I first got this and read it, it says insert pen, P-E-N, insert pen into jacks or whatever, and I'm looking in the box for a pen. I thought maybe it had a, I don't know, touchscreen or something on it. No, the pen is your probes. They call these that plug into them. I'm not even on camera, but I'm not going to worry about it. They call these here pens. Okay? Chinese translation to English, I guess. I don't know. But you got to read between the lines on the instructions. But overall, they're okay. So let's go into resistance now. I got to get you set up for that. You already know the 2 meters are pretty close. So let's try some resistors. Okay, brown, red, brown. $120 ohms. Okay. 1 ohms on this fluke, 73, 1 auto on that one. So we are going to hook up. We may have to put some extra clip leads on this. We'll see which meter reads what here. All right. All right. What did I do wrong here? All right. Just a second here. I'll be right back. All right. Can't do it. You can't measure an ohm meter, a resistor, a 120 ohm resistor, with 2 ohm meters. I just learned that. Unlike reading 2 voltages, whether it be AC or DC, you can use 2 meters, you know, with the proper polarity connected, and you can compare them. But here we got a 120 ohm resistor. The white wire is connected to both red wires on the meter. The green wire is connected to both black leads on the meter. Now if I take off 1 meter, there's your 120 ohms, 120.6. Okay, if I put that back on to try to get my fluke, the fluke is reading 373 ohms. That's cuckoo. Cuckoo. So, what we got to do is to disconnect the new meter. I just learned something. I think this is the lead. We'll find out. And there's your 120 ohms here. So, you and I both learned something today. So, apparently, if you want to compare meters on ohms, you got to do 1 meter at a time. But you can see it's 120.9. So, they're pretty damn close. Okay? So, we already checked the DC. We already checked AC. We already checked the frequency. The frequency response of this meter for reading as a frequency counter is limited to 40 cycles per second to 1,000 cycles per second, which is good enough. You know, you want to read anything more in a range, you use a frequency counter. Not a problem. For what I'm going to be doing, this is ideal. So again, I want to thank you, and I figured I'd make this video to show a comparison. Now, I supposedly understand that this meter will read up to 60 megohms. Well, I don't have a 60 megohm resistor, I only have a 10. But let's give it a try. We'll not use the fluke now. I just wanted to compare voltages and resistances. Okay? I don't think the fluke will read over 10 megs. I'm pretty sure. I think the limit is 10. it's been too many years, and I don't run into resistors that are usually more than 10 meg unless they've gone up in value. So let's get this out of the way, and let's hook this up. Matter of fact, I'm going to try to take this and put this in this stand here, because this stand here has got to dry, and now it's not ready to use today. Be right back. Okay, so when you first turn the meter on, it gives auto. On the other case that I made this for the Fluke 73, I designed the other case to accommodate these test leads that come out the bottom. And I got a couple of finish nails in it. You'll see when I get it done and get the clamps off of it, that is going to sit like this, and it's going to hold them off so it's not resting on this. And it's made a little differently, and I'm not done with the design yet. So I don't really like this arrangement, but it is not designed for this meter. Because when I built this, it's designed for meters that have the leads coming out the front here, not the bottom. So, not a problem. I love making things out of wood, and that's why I will have this thing done, and I'll probably paint it. Speaking of paint, that paint is still sticky on the power transformer, so it's 3 days now. It will dry. It's very, very slow drying oil-based paint. Anyways, I have here some 10 meg ohm resistors. So, the problem is going to be trying to do them in series. I'll have to twist them together, and I don't like doing that, but I will do it. So, I use clip leads because I always get wrong readings when I try to hold the leads on. So, we're going to add clip leads to the test leads. So, we're going to do... We'll use green on the black. It doesn't matter. We're not reading. By the way, this reads capacity too, but it reads in nanofarads. And nanofarads drive me nuts. I can't find my conversion chart. So, I have great difficulties with nanofarads. That's the only thing I don't like about this. If I'm using this for capacity, it reads nanofarads. Now, if I put a 1 microfarad in here, it will read 1 microfarad, UF microfarad, or MF microfarad. If you look back on your old radio schematics, MF or MFD was microfarads, or like 0.01 microfarads. I'm from the old school, and that is what I use. Okay, you're not teaching this old dog new tricks. It ain't gonna work. Alright, so the first thing we're gonna do here is we're gonna put a 10 meg in here. Alright. Let me get my magnifier so I can see if that's in the screen. Oh yeah. It reads 1105. These are Chinese resistors. You know, they come on a pack like this. I got like 1,000 of them for a very, very cheap price years and years ago. All right, so that's a 10 meg. Let's try another 10 meg and see if that reads way off. You don't want to... On a high resistance like this, I think most of you guys know that, you don't want to put your fingers across this. That reads 10.32, because here's what will happen. You put your fingers across it. Look at the meter. Let me just keep my hands on it. It drops way down, doesn't it? Let me do that again. All right, so no problem reading 10 meg. So I just wanted to point that out. When you're reading very high resistances, you don't want to I don't like doing this because I can't use the resistors. They won't be neat. But these leads are so hair thin, you know, it's not good. Not like the good old carbon comp resistors of years ago, where the leads were decent and heavy. All right, now we should be reading 20 meg. 20.38. Can you see that? This is what we are. We're in series. My substitution box won't have resistors that go up that high, so we'll add another one in here. And this one here has already been twisted around here. Oh, we'll probably make a mess of that too. Things I do for you people. All right, so what we've got now, we should have 30 meg in here. We'll connect the other lead. We'll find out. Now it's loose. I can feel the connection's loose, so it might jump around. Yeah, that's exactly what it's doing. Let me see if I can hold it out tight like that. There's your 30 meg. But if I let it flop around, the connection will get lost and it'll jump all over. So that's 30 meg. So we know the meter will read up to 30 meg. Will it read to 40 meg? It's supposed to read to 60, so I'm pretty sure it will without any problem. But I don't want to twist up all my leads on my 10 meg. 10 meg is used in vacuum tube circuits. So we should be 40 meg. 410s in series. Resistors in series increase the resistance. Here we are, 41 meg. 41 meg. Okay. I'm not going to read anything higher than that. I'm not going to twist up the rest of these. That's all I got right now. So I'm pretty confident that this will read to 60 megs, because that's what the book says. Beyond that, it says it'll just give a row of dots. In other words, it's over range. Okay, so we know it works very well on high resistance. Let's turn it off. Got to hold it. Okay. I'll be back. All right, let's turn it on. As I said, it goes into auto. Of course, it always goes to Celsius. Like I say, they don't say nothing about Fahrenheit in here. I don't use Celsius. Okay, so we got two resistors here. Two types of resistors, a 1 meg and a 6.8 thousand. Okay? Now, you remember me having all the problems trying to read that other meter where I couldn't tell if it was reading in megs or 1,000? This is going to read down at the bottom here where you can plainly see. And I appreciate that viewer thinking of me in that, because I was happy with the Fluke 73. That's one of my favorite meters. I've had it for many, many years. But this is even better because it's got a bigger display on it, and it's all automatic, almost. There's other things you have to set manually. But I'm not here to review the meter. I am here to kind of like just show you and give a shout out to whoever that viewer is that sent it to me. All right, this is 1 meg. Again, one of these Chinese resistors. 1.035 meg. There's your M in ohms. Now, I still got the screen protector on. You know, I leave the screen protector on, even on my cell phone, my flip phone. don't get scratched up that way. Yeah, it's a little bubbles in it because that's the way I got it. Eventually I'll take it off. But around in the shop here, things fly, solder flies. You know, when I'm doing work, I get sloppy. What can I tell you? All right, so, we're reading 1.41 meg. Yep. Okay. So that's a 1 meg ohm resistor. And I can plainly see that. Now, let's read 6.8 K. We'll get a 6.8 K out of here. Unless it got dropped in the wrong box, it should be 6.8 K. You know what? My eyes! 68K! Not 6.8, 68K. That's my own handwriting. Hey, old goat, you old fart, you're blind as a bat. 68K. But you see, it's reading, let me get my magnifier, I'm sorry, K ohms. 68 K ohms. 1,000 ohms. There it is. So that's going to be very helpful for me. So for now, I got this in here just to give you the demo. And I want to show you a little bit, if I can get it all into screen here, of how this thing is designed. I don't really want to take the clips off, the clamps I should say, off of this yet. But let me try to get it a little closer so you can see it, and I'll try to explain. It's nothing complicated, but I just threw it together yesterday. Okay, the way I designed it, the meter slips in like this, okay? And this part here is shorter, so I can get my fingers in on the side controls over here, okay? These two finish nails down at the bottom, and it's hard because I got these clamps on, keeps it from falling down. I got a finish nail on each side where the probes go. One here and one here. I know it's very difficult with the clamps in the way, but I only glued this a couple hours ago. I cannot take these clamps off yet because I had to extend the bottom. So let me get this meter out of here before I drop it on the floor. I'm klutz. When I built this, I had a scrap piece of 3/4 inch. Let me try to get this back more so you can see it. I built this out of a scrap piece of 3/4 inch plywood, okay, the base. What I did is I took my skill saw, my small one, 5 inch, and I cut it on an angle. So that angle is like this. So the other half of the piece that I cut off of here is over here, and I made a slope. Then I had 2 pieces of trim, but I hand sawed it with a small saw to get the angle here. It's way too small to use the skill saw. However, when I built it, it tipped back. The wood wasn't long enough, so I couldn't make a back to come out more. So I added another piece of 1/4 inch Luan and brought it out here, so I make another base. And it also hides the screws that I put in here. There's a piece of Luan in here. This is a scrap piece. I save everything. I make my stuff out of wood there, Doug. Oh no, you're not doing cardboard anymore. You're making things out of 3D printing. I love working on wood. I don't like making things out of plastic. That's just me, you know. That's just me. Anyways, So now I got a good base on here, and it's not going to tip over, except, well, it's pretty wide. Not sure how wide it is, over 5 inches, I guess. So it's going to slide in here and sit on these 2 finish nails. It's not going to hurt anything. I'll experiment with this, and if it appears that it's going to fall forward, I'll have to figure something out. Maybe putting a little Velcro in here or something. And on the back of the case of the meter. Here. It's not going to hurt anything, but that's only if I need it. So, I got some sanding to do yet. I might get picky and put some wood filler in here, if I can locate it. It might have got frozen up over the winter. And I'm going to paint it, but not right away. So, I threw this together at 4:30 yesterday afternoon. Not this part. I added this. Let's see, when did I do this now? Yeah, I did everything yesterday afternoon at 4:30, and I finished about 5 o'clock, just in time for the 5 o'clock news. A little after, okay? Today I added this 1/4 inch loo on here. So that's why all these clamps to hold this on. So it's not nailed at all, it's strictly glued. So that'll be a holder for the new meter. And I may make another one for my other meter. Occasionally I do use the orange one too. But I'm going to be using this new meter here a lot more often. So there's more on the book. And I would recommend you watching one of the videos, especially the longer one. It's more thorough. It tells you a lot about it. There's a couple of things I'm not sure about, but it's features that I don't use, like non-contact voltage. I wouldn't use that. They make these portable things that are like a pen, where it takes a AA, and you know, I use it. I use those. But it has the feature. As a matter of fact, the orange meter, I think, has that too. I'm not sure. One of my other meters has that. But, again, that's it. I'm boring you. I'm probably repeating myself again. But one last thing. Upside down, naturally. There's no name on this. Made in China. It's just a bunch of numbers, digital multimeter. That's all it really says. But if you do a YouTube search, if I remember, I'll put the link there. If I remember. I'll put the link to the video I like on this. Because it explains it pretty good. And, but it's a different, it looks a little different. The review has only 2 buttons on this side instead of 3. But it looks identical, and it has only 1 light on the flashlight. That's the only thing I can't get the light on, but that's not a problem. I'm sure if I study the book enough, I'll learn. But I wouldn't use this for flashlight anyways, because it's going to drain the batteries. All I got is a couple of used AAA batteries. AAAs, other than used ones, I haven't got any. And I got to get to the $1.25 tree. It's no longer a Dollar Tree. It's a $1.25 tree. I wish they would change the name to a $1.25 tree, because that's what everything costs now. No more dollar. I'm lucky to be able to get a cup of coffee at McDonald's Senior for a buck. That'll be going up before too long. Okay, so again, The only name you got is right here. So you might get something on YouTube about that. But if I think of it, I'll put a link to a meter that's very, very similar to this and is very helpful. Okay, that's it. I want to thank the viewer that sent this to me. If I knew who it was, I'd dig into my stash and send you some money. I appreciate it. Thank you very much. And I hope this is helpful to anyone else. I highly recommend this. It's a damn good meter. Thank you, and take care, everybody. And thanks again to that viewer that sent it to me. Take care, everybody.